All right, so how many 5-card hands are possible using a standard deck of cards? So if you're not that familiar with the deck of cards, they do have a picture of that standard deck of cards in this section, 10.3. It's for this particular book, it's page 557. That may change time to time, but anyway, what you have on a standard deck of cards is there's four suits, hearts, diamonds, clubs, and spades, and each suit has ace, 2 through 10, and then jack, queen, and king. And then just some distinctions on those. The hearts and diamonds, of course, are red, and then the clubs and spades, those are black cards, considered the black cards. And then one other distinction, the jack, queen, and king, those are considered face cards. But altogether, so if you put that all together, you got 10 cards, 11, 12, 13. So there's 13 cards in each suit. We've got 4 different suits, so there's 52 cards. For this particular question, that's all we really need to know. We've got 52 cards altogether. Put all that together. All right. So how many 5-card hands are possible using a standard deck? So yeah, we've mentioned now that you have to basically ask yourself when you confront one of these counting problems, is it a combination? Well, it's a combination if the order doesn't matter. And in hands of cards, yeah, the order doesn't matter. If you rearrange your cards, whatever 5 cards they are, if you just rearrange them, it's the same hand of cards. So the order doesn't matter on hands of cards. And so for that reason, yeah, this is a combination since the order doesn't matter. So, yeah, so it's a combination. And like I said, we've got 52 total cards. And I want 5 of them at a time. So if we do the old combination there, 52, 5, 52 choose 5, or however we say it, that'll tell us how many 5-card hands we've got. I get 2,598,960. So there's quite a few of those. Is that all right? Okay, now, variations of that. All right, so how many 5-card hands have only face cards? So this is number 1, let's do number 2 here. How many 5-card hands have only face cards? Well, no need to worry there. If it's a hand of cards, it's a combination. So we'll just say that. So this is a combination. Now, we don't have 52 cards here to choose from, right? Because I only want to have face cards. How many face cards with the restrictions we talked about over here? How many face cards are there? 3 in each suit. And there's 4 suits, so there's 3 of these in the hearts, 3 of these in the diamonds, 3 of them in the clubs, and 3 in the spades. So there'd be 12 altogether, right? 12 face cards total. And so in this case, that's all we want to choose from. And so that's our n, right? The n here is 12. Again, I want 5 of them at a time, so this is a combination of 12. Choose 5, 12,5. Is that all right? How many is that? 792? 792. Okay? All right. Now, third variation of this problem. So how many 7-card ends have 5 hearts and 2 black cards? Seven card hands, but 5 hearts and 2 black cards. Well, once again, the question is, how do we make it where we only have hearts and black cards? Well, we kind of did this with a previous example here, where the way we can do this is split it up. It is a hand of cards, and so it's a combination, but just do 2 separate combinations. Do a combination for the hearts, and then a combination for the black cards. All right? 2 combinations. Now, for the hearts, how many hearts are there to choose from? Well, again, each suit has 13 cards. Hearts is one of the suits, so there's 13 hearts. So I can choose from those 13, I'm going to choose 5 at a time. What about the black cards? Well, again, there's black and red, so the clubs and the spades are black, so there's 13 clubs, 13 spades, 26 total, yep. 26 black cards, and I want to choose 2 of them. So I'm going to do those 2 combinations. With me? Make sense? 13, choose 5. Combination. That's 1287. 26, choose 2. Combination is 325. So I've got these 2 numbers. What do I do with them? Add them or multiply? What's this word? And? Remember last time what we talked about? And means multiply. And means multiply. So you multiply those 2 together. So that's 418,275. Okay? All right, so let me do one more of these counting problems and we'll move on. So as you may have already figured out, it's there's really the way I'm doing it. There's 2 options. You're going to do combinations or you're going to do blanks. Now sometimes the blanks turn into permutations or factorials, something like that. But there's really just 2 options. And so combinations, or I call it blanks, but you know what I mean. So if it's a combination, you got to use combinations. But if it's not a combination, just use the blanks. Okay? Don't get into thinking, well, is it a permutation? Is it factorial? Is it? Just use the blanks, and the blanks will tell you if it's a factorial or something else. But those are the 2 options. And so whenever you come across a problem, is it a combination? And again, it's a combination, like in the hands of cards, if the order doesn't matter. If the order doesn't matter, it's a combination. Okay? Otherwise, it's blanks. And we've seen a couple of examples that are combinations. committees are combinations, hands of cards are combinations. There's other possibilities, but those are two of them. But that's what it boils down to. So when we come across a problem, all right, so here's one. How many 4-digit numbers can be formed using 0 through 5 digits that are even numbers? All right, so maybe we've done one like this previously, but been a day or two. All right, so what do I do here? Is it a combination or is this blanks? Is this a combination? Is this a combination? Does the order matter here? If I have a 4-digit number and I rearrange the digits, does that change up the number? Yes, it does. Okay, so the order does matter. So it's not a combination because the order does matter. Okay. The order doesn't matter. That's when you use the combinations. So what do? Use the blanks. Okay. If it's not a combination, you're going to use the blanks. So we got a 4-digit number. It's going to be the blanks. What I would say on this one is, if we have some type of special restriction, that's where I would start. In this case, we've got that it's an even number. And how is a number an even number? Well, it's the last digit, right? To be even, this number over here has to be an even number. And so, since it's got to be even, which one of these could I use over here for the last digit? Well, I could use 0 or 2 or 4, right? If it ends with one of those, it's an even number. So there's three choices for the last digit. So that's, I guess there is one more with the restriction, but that's the big restriction on it. This one has to be either a 0, 2, or 4, so there's 3 possibilities. Now, if we go back to the first digit, does it have to be an even number? No. It can be anything. It's just that last digit has to be even. So how many choices are here for the first digit? There is a restriction on it, but it's not that it's even. What can't the first digit be? It can't be 0, and so that limits me to 5 here, 1 through 5. And then the second and the third one, they can be anything. It doesn't matter. So these can be any of the 6. And then it doesn't say anything about repetitions or anything. So fundamental counting principle then says multiply those. So that gives me 30 times 18. Is that 540? Yeah. All right. Question or concern? Look okay. All right. Well, what we also need to talk about